Hello everyone, this is the biology content video for Unit 4, Genetics and Heredity with Section 2, and we're going to talk about Punnett Squares today. We're going to answer the question of how can Punnett Square be used to predict the phenotypes in the offspring of a cross, that means a breeding or a mating, from parents with known genotypes. So we're going to be working with known genotypes with whatever we are actually doing the cross on, and we're going to try to predict phenotypes. We can also predict possible genotypes, all right, and we can say here are the different genotypes that will look a specific way as well. All right, so let's go ahead and get started. So this is modeling the inheritance shown by Gregor Mendel that we just talked about in the last section, and it can be applied to any allele that has a dominant and a recessive type, all right? And it's going to always show the genotypes, and remember, if you know the genotypes, you can tell what the phenotypes look like. So in our example here on screen, we have a homozygous recessive. This parent has a lowercase allele and a lowercase allele. That means they're both recessive. This one has a capital letter and a lowercase letter. That means this capital letter is dominant. Remember, that is our nomenclature. That's how we tell if it's dominant or not. We look at if it's uppercase or lowercase. And we're just going to blend these two together. So this square, this possible offspring, gets a capital G from this parent and a lowercase g from this parent. So it has a dominant allele and a recessive allele. This square, this possible offspring, gets the same capital G dominant allele, but this recessive allele instead. I know that these both are recessive, they look exactly the same, but we are using each column and each row to show different allele combinations. So this one, this allele, and this allele. So it looks exactly the same genotypically and phenotypically, right? Because they are both heterozygous dominant. These two possible offspring are going to get this recessive allele and this recessive allele. So it's going to be homozygous recessive. This possible offspring has homozygous recessive as well, but using a different allele from this parent. As a note, a lot of times the male parent gets put on top and the female parent gets put on the bottom or the left side. It doesn't really matter though, right? If we switch these two, we're going to get the same results. A 50% genotypic presentation of green seed pods and a 50% presentation of yellow seed pods. Right? If we wanted to answer the question of which genotypes are possible, we'd get the same result, right? 50-50. Looking at it slightly different way, right? This is a wrinkled green and a round yellow. So we're looking at two different alleles, but looking at them the same way. So we can combine these and use one Punnett square instead of having to do two different Punnett squares for this same cross. So this is a monohybrid cross with multiple alleles. So a round yellow that is dominant and homozygous, right? Because it's got two capital R's and two capital Y's. So both alleles are homozygous. They're the same, and they are dominant. So it's going to be round and yellow, capital R, capital Y. The wrinkled green, wrinkled is a recessive trait here, and green is a recessive trait. So the only way that it will present as wrinkled and green is if both its alleles are recessive. So we know that it can pass down a capital R or a capital R, and lowercase r and lowercase r, and a lowercase y and a lowercase y. So we're going to do the same thing we did last time and bring a capital R from this parent and the lowercase r from this parent. So we've got a heterozygous for the round trait with the dominant round, right? And for the other trait, we're going to bring this dominant Y down and this recessive Y over to here. So we've got a heterozygous for both alleles, but it shows with the dominant traits of round and yellow. Now, continuing on, we're going to get the same exact result for the other four offspring here. So there's a 100% chance that the offspring is going to be round with a yellow color, and it's going to be heterozygous for both traits. Now, what if we were to breed these two offspring, right? Or these two, and we did a, say, like, this is the F1 generation, right? Using that nomenclature we used last time, these two parents. But these four are the F2 generation. What if we wanted to make an F3 generation by interbreeding these? Well, then we're going to need to do a little bit different type of Punnett square. It's still a Punnett square. It's still the same concept. It's just bigger. Okay, so remember that each parent can give one allele. So this parent can give an R, capital, a lowercase r, a capital Y, or a lowercase y. So we're going to need more than 2 squares here. We're going to need 4 squares. So using those same parents, right, we've got round yellow and round yellow from here, the round yellow ones. Oh, my bad. Put to the wrong screen. So these can give a capital R and a capital Y, a capital R and a lowercase y, a lowercase r and a capital Y, and a lowercase r and a lowercase r. So it could give homozygous, it could give just dominant traits, it could give just recessive traits, or it could give a mixture of both. Same for this other parent because it's the same generation, right? They have the exact same genotypic makeup, right? And a lot of times when I'm doing, especially the dihybrid crosses, I like to remind myself of what all these letters mean. So I just throw a key over here, and I might do that on like the side of my paper over in the margin, just so that I remember and don't forget what the capital versus the lowercase are, because it doesn't always work, right? Like Y stands for yellow, but a lowercase y means green. It doesn't mean like light yellow or something. Lowercase r stands for wrinkled. So I want to make sure that I remember and don't mess up something easy to throw the whole system out of whack. So we're going to do the same thing that we did for the other Punnett squares, right? We're going to take this capital R and we're going to put it here for everything in this column. And you can work this out the same way. Take this capital R, put it everywhere. This lowercase r, put it everywhere. This lowercase r, put it everywhere. Bring this capital Y, put it here, and then here, and then here, and then here, right? And work vertically. And then work horizontally. This R is going to be put here in this second slot, continuing on, all right? It goes here in the first slot because dominant is always wrote first, right? We always write the dominant traits first. So this capital R goes there, that capital R goes there, because this lowercase r completes that set of 2 for the allele, possible traits. So as you continue to do this for all 16 squares, I know that's a lot more. Like I said, same concept, just bigger, just more work. We're not going to do a whole lot of these in my classes, but a lot of times this shows up on end of course exams, it shows up on the ACT, and it'll ask you different things about it, or it might have a few of these put in and ask you to infer something about the parents, right? One of the things in the AIR test here in Ohio that has shown up a couple of times is using this, but with mutations on those alleles. And we're going to talk about mutations a little bit, but we've already covered those. So remember, that stuff, it keeps coming back, right? So there is a 9 in 16 chance, because there are 4 plus 3 plus 2, that are phenotypically round and yellow. Now there are multiple different genotypes that are represented there, right? We've got a homozygous for both alleles. We've got a homozygous for the round versus wrinkled allele, but a heterozygous for the other allele. And that is going to continue, right? So there's multiple different genotypes, all representing this one phenotype. So if you're asked a question, make sure you're answering it versus phenotypic versus genotypic, all right? Because those are two different questions. One is asking how it looks. One is asking about the letters, right? The different kinds of alleles. So there's a 9/16 chance it's going to be round and yellow. There's a 3/16 chance that it's going to be round and green. There's a 3/16 chance that it's going to be yellow but wrinkly. There's a 1/16 chance that it is going to be green and wrinkly. because that's both recessives, right? Very, very uncommon for it to get both recessives. Right, so that's how we use it to predict phenotypes. We can also predict the genotypes, though, right? Because if we know what the genotypes of the parents are, we can get the genotypes of the offspring, and that's how we talk about those phenotypes. For my class, at least, if you can keep putting them in ratios or fractions, we're going to be okay. You don't have to put them into your calculator and get a perfect percent. But remember, if it's something common like 3/4, you should know that that is 75%. If it's something easy like 1 to 1, that's a 100% ratio, or a 50-50 ratio. 1 to 0 is 100%. All right, so keep these things in mind. Math and science are very interrelated. We're only using a little bit of math. We're using a lot of common sense and just remembering how things are plugged into our model to generate a new set of offspring. All right. Keep learning, everybody. Have a good day.